Bandwidth for First Updates Now is supported by AndyMark. Are you competition ready? Go to andymark.com and keep your team inspired. And by the Blue Alliance. Keep up to date on all live and archived First Robotics events and team stats at thebluealliance.com. First Updates Now is brought to you by Twitch. Fun is now a Twitch partner and offering some awesome subscriber-only benefits. Subscribe today or get a free subscription each month when you have Amazon Prime by linking your account and clicking subscribe. Good evening, everybody, and coming up on First Updates Now, we get a fantastic show for you today. It's time to get down with the fundamentals of LabVIEW, where we'll get the inside scoop and expertise on how LabVIEW could help your FRC team specifically in source code control. We have some awesome prizes for those watching live today, including a robo-reel courtesy of National Instruments. From First Updates Now, I'm Tyler Olds, and I'm delighted to welcome your guru and guide as we complete our LabVIEW journey from National Instruments. Please welcome April Riddett. How's it going, April?
Hey Tyler, thanks for the introduction. My name's April. I'm an applications engineer here at National Instruments. I've been involved with FIRST for the last couple years now, and this is our last Fundamentals of LabVIEW episode, Tyler.
I know, it's been a journey, right?
It really has.
Can we talk about what have been some of the previous topics that we've gone through, and how does that kind of lead up to what we're going through today?
Sure. So we started with the basic fundamentals of LabVIEW back in episode 1, going through how do you set up a robot project? What does the basic LabVIEW robot project architecture look like? Moving on in episode 2, we looked at adding kind of the next steps, adding vision to your project, adding some PID types of control loops to your project. Episode 3, we focused on command to control, which is an alternate subsystem-based architecture that you could use. And in this episode, we're going to look at using source code control to manage your code a little better, both in the standard LabVIEW Robot Project and in command and control. And we're going to go through the top 10 tips and tricks for LabVIEW and FRC.
Nice. And speaking about tonight, too, we do have some, April's put together some really cool trivia questions in chat as well. We have some cool prizes from AndyMark that we'll be giving away, so stay tuned for that. Don't forget, in order to be eligible, just click that little follow button right there. We'd appreciate your support for that. Or if you're interested in more and like to help support First Updates Now, go ahead and click that subscribe button and get you a chance, an extra chance to win prizes tonight. We also, we'll start the Robo-Reel giveaway a little bit later on in this presentation, so make sure you pay attention. Make sure you get everybody from your team in chat ready to go for that, because you'll get more entries to win for that as well. If you do have any questions, by the way, for April about LabVIEW, or well, you can probably ask her anything, right? Go ahead and tag at First Updates Now in chat with your question, and we'll get to those at certain break times as we go through. So April, you ready to go into the presentation?
Yeah, let's jump into it.
We can jump right in. Let's go ahead and do it.
All right, so as you guys know, this is from National Instruments. We are on Fundamentals of LabVIEW episode 4, episode last. LabVIEW is used really heavily in universities. This is one of the reasons why it's so valuable to start learning these skills in your high school career. It's used in 110 different countries and over 7,000 universities worldwide, which is pretty incredible. So getting the start now will really set you up for the future. The LabVIEW Continuum really aims to bridge kind of all the way across your educational and your career, starting in kindergarten with junior FLL, up through FLL, FRC, moving into, like we said, universities, and then on into industry. Looking at the next slide, these are some of the biggest companies that use LabVIEW. These are not all of the companies. We have over 35,000 companies that use LabVIEW worldwide, so we obviously couldn't fit them all on one slide. But looking at the next slide, I did want to call out one company that uses LabVIEW that had a pretty exciting day on Tuesday.
Hell yeah,
if anyone watched that. This is two pictures of SpaceX's mission control room. The larger one on the left side of your screen is from a few years ago, and the small inset on the right side of your screen is actually from mission control on Tuesday. They do all of their testing, all of their mission control in LabVIEW. You can see the front panels there. So that was really exciting for SpaceX and for us to be supporting them as they go to continue to discover and innovate these engineering feats. So that was a really exciting day.
So, April, you were telling me a little bit earlier before the show started that you guys had a big party yourself for the SpaceX launch. Can you tell us a little bit about that?
Yeah, we were super excited here at NI to see how successful that went because we do work so closely with them to support them through testing from concept to like first engine tests to testing the whole rocket to grabbing that data off the rocket itself and sending it back is all done through LabVIEW. So having a hand in that and being able to support engineers who are making these incredible discoveries is just awesome for us. That's what we aim to do, and it's really exciting to see that all kind of come full circle. So let's move on and talk about LabVIEW itself. We're going to start with source code control. We'll talk a little bit about what is source code control, why do we use source code control at all, and then how do we implement that in a standard LabVIEW robot project and in a command and control robot project. So we're going to look at both sides. So what is source code control? It's also known as version control or revision control. It helps bring together different pieces of the same overall project. It helps keep when you start working on one VI and then you finish that one, and maybe the next time you meet, you work on another VI. Source code control helps keep everything current and relevant and working together kind of across your project. It's really helpful, especially when you have different developers working on the same project. Of looking at the next slide and why do we use source code control in the first place, it does allow for parallel development on the same project. It helps ensure that developers are all working on the most up-to-date version of the code. So you're not sitting here making code updates to one version when Tommy across the room has a newer version, and when he pushes his updates, yours are going to get overwritten. That's what source code control helps prevent. It enables multiple team members to work on one robot code project without overwriting each other's code. So in this example, if Susie was working on the teleop VI and Tommy was working on the autonomous VI, they could both get sent up to the same robot project and be pulled at the same time when your main developers or your hardware team goes to put code on the robot. So let's look at how we use source code control in a LabVIEW robot project. We're going to kind of go through the steps to set your project up so that you can push it to any kind of source code control software, be that GitHub, be that some other software your team uses. We're going to get your LabVIEW project ready to be pushed to a server somewhere. So the first step is you're going to want to ensure that your project is saved somewhere you can find it easily. Putting it on the C drive in a folder called Robot Project is a great place, as long as you know what that file path is, because that's the path you're going to need to push up to GitHub and kind of keep track of to make sure all your files go to the same place. We're going to want to navigate to this folder through the Windows Explorer, so kind of through the basic file structure, not in LabVIEW yet. And in your robot project folder, we want to create a folder with a meaningful name to store all of the team SubVIs. You can see here the folder I chose to create was called SubVIs. It can be as simple as that. It doesn't have to be fancy, but you don't want to call it new folder 22. We want to know what's in that folder, and that name is important. Looking at the next slide, the next step we want to do is actually open up our LabVIEW Robot Project, whichever project we're working in this year, and add a virtual folder to the robot project. These virtual folders are those gray folders you typically see in the LabVIEW Project Explorer window. You can right-click on the team code folder that you'll already see in there, go to New, and then Virtual Folder like I've shown on the slide here. It doesn't matter what the name of this folder is because it's going to get overwritten in the next step. So you can leave this as new folder. You can call this folder name to be overwritten, really whatever you want. It doesn't matter. In the next step, we're going to want to convert that virtual folder to what we call an auto-populating folder. Auto-populating folders automatically sync with the folder on your PC. That's why they're auto-populating. They automatically populate all the files and folders that you put into them through the Windows Explorer will automatically get pulled into your LabVIEW project as well. So when you click on this folder, you can right-click on the new virtual folder you created and go to Convert to Auto-Populating Folder. When you click that, it will bring up a Windows dialog, much like an open dialog, and you can navigate to that folder we made in the previous step. So the one I called SubVIs, I would click over and find that folder. When you select that folder, you'll see that your virtual folder name will update to match the actual folder name that you called it in the Windows Explorer window. That's why the first name matters and the virtual folder's name doesn't. So on the next slide, we talk about the difference between virtual folders and auto-populating folders. Virtual folders are these gray kind of colored folders. They only appear in the Project Explorer. You'll notice if you go look where your LabVIEW Robot project is saved on disk, you won't see a folder called support code or team code. They're purely in the Project Explorer to help organize your VIs. It makes it easier for you to find VIs, things like that. These don't affect where files are stored on the computer. Auto-populating folders are going to be this blue icon with a yellow cylinder on it. These actually correspond to a folder on your PC. So you can see that the name of my auto-populating folder now exactly matches what I called the folder on my PC earlier. And like I said, any new files that you put in the folder on your PC will automatically get brought into the LabVIEW project the next time you open the project folder. So the power here is that you can take a teleop VI, just the teleop VI, not the teleop VI. You can take any kind of custom VI that you've made, drop it into the auto-populating folder, and the next time you open up your robot project, that VI will get pulled in and updated across your robot code. So if we go to the next slide, you'll see that you want to add any team-based VIs to this auto-populating folder. So if you make a VI, for example, that says pick up cube or drop off cube or put cube on scale, anything like that, these would go in the SubVis folder. And like I said, any new or updated VIs will get synced back to your LabVIEW Robot project. This helps ensure that your VIs are going to be correctly linked to your project. I don't know if you've ever opened up a LabVIEW project and gotten some errors that say, hey, I can't find this file, or hey, the file path for this has changed, and you have to go through and relink everything. It can really be a pain. So this helps ensure that nothing gets unlinked and everything is going to kind of talk to each other across the LabVIEW project. At this point, you can upload the whole project folder to GitHub, to anything like that, and the rest of your team will be able to access it from there. These are kind of the steps we need to go through to set up a standard LabVIEW Robot project to work with source code control software. One other thing that can be really helpful, especially when working with a standard LabVIEW Robot project, is to use Stub Vis. Stub Vis are mock VIs that will eventually be replaced with VIs with functionality in them. They really allow for you to build up higher levels of code without needing the low-level functionality yet. So for example, if you're using you could use a Stub VI for pickup cube as part of the autonomous independent development because you might not have developed what actually goes in pickup cube yet. You might not know how many motors you have. You might not know if you're using pneumatics. You can develop the rest of the autonomous program without having these details. So if we look on this side here, you can see the front panel and the block diagram of what a Stub VI would look like. We have everything we would need on this front panel. The motor reference in and the motor reference out are those two really big clusters. You don't have to worry about making those, just drop a motor reference control down. And then we see that we have a Boolean called is the cube picked up. I've made a SubVI for that, excuse me. But if we look on our block diagram, nothing happens in this VI. We pass the reference in, we pass the reference out. We've set our Boolean to always be false. We could have another programmer go in and define the functionality of this code later, but I could still be sitting here building up the rest of my autonomous program. Like if we look at the next slide, you can see that I've got some stuff happening. I've put in a case structure to act off of the Boolean output of my cube pickup VI. I don't know what that Boolean is yet, but I can build the rest of my code around the expected functionality without having that low-level functionality implemented yet. This is really why we'd want to use Stub Vis here. It helps you continue development even if you don't have the core functionality yet. So some tips for using source code control with the standard LabVIEW Robot project: keep your VI names consistent. If I called that Stub VI I just made pickup cube VI, I would want to continue calling it pickup cube VI because if you change the name, you're going to create a new sub VI. So make sure your naming stays consistent. This does work best when each developer has kind of a modular mechanism or behavior to program. In that case, maybe one of my programmers was working on developing the code for the pickup cube VI while I was working on Auton. It's a little bit harder to have two people concurrently work on a VI on separate machines. And by a little bit harder, I mean don't do it. And then don't create new robot projects, create new VIs. You can do this by going to new VI from the splash screen. That's getting started window. This just helps to ensure that you're not overwriting someone else's teleop VI or any of the other predefined VIs we have in the robot project. And really communicate within your team. Talk to each other. Hey, what are you working on? What can I help with? What needs to be done is really a good way to make this an effective distribution of work rather than no one ever getting to programming the pickup cube VI until it's the day before competition and you suddenly realize that you haven't programmed this VI yet. So kind of switching gears a little, let's look at using source code control in a command and control project. Command and control is much more suited to source code control than a standard robot project. It was built with the idea of multiple developers working on it at once, and these subsystems really help to enforce modularity across the project. It also automatically creates these auto-populating folders we were talking about for the subsystems. So let's take a look at what happens when we make a standard command and control robot project. So all I've done here to get this Project Explorer window is create a robot project using the command and control template. You'll notice that all of the folders already have the auto-populating icon on them. These are going to automatically update when you make changes. Again, you'll want to save this project somewhere simple, somewhere you can find. Saving it on the C drive works great. Saving it under your user drive works great, as long as you know where it's going to live. So the next step for kind of any command and control project, but particularly when you want to use source code control with it, is to really plan out the functionality you'll need for the robot. Sit down and figure out, okay, what tasks does my robot actually have to do, and what subsystems am I going to need to implement these tasks? By creating the necessary subsystems and the commands within each subsystem off the bat, you'll automatically create not only the auto-populating folders, but also the stub VIs for each of those commands. At this point, once you've gotten this far, you can go ahead and put that project up on GitHub or any other source control software. You can always add new subsystems if necessary. Just make sure that they're added from the main project file. Note how this was a lot easier to do than with a standard LabVIEW Robot project. It's just a lot less effort, keeps your project a little bit cleaner, and is, like I said, is kind of designed for source code control. So some tips for using source code control with command and control. Like I said, plan ahead is really key here. What do you need the robot to actually do? And then what actions does the robot have to take to accomplish that? For example, if we are looking at the idea that we want our robot to drop a cube in the switch, the robot has to pick up the cube, carry the cube to the switch, move from position A to wherever the switch is, and then drop the cube off. That's several actions that kind of fall under one goal for the robot. So being sure to think that through as you're planning out your code is really critical with command and control. Again, this does work best when developers are working on separate subsystems or separate commands. Just kind of, again, working on enforcing that modularity. Having two programmers working on the same VI on separate machines doesn't really work. You can't really copy and paste lines of code in. You can certainly copy and paste SubVIs in. That's a great idea. But either work in teams, work in pairs, or give everyone their own subsystem or command. Command and control does a really good job of breaking that down into individual pieces, so there's lots of little bits for everyone to work on. Communication is, again, really, really key. Talk to the people on your team. Make sure they know what you're doing, you know what they're doing, and you're all working towards a common goal, rather than potentially designing code that doesn't work with each other or something like that. Are there any questions on source code control? Notice that he's thinking about auto-populating folders. Those are those little blue folders with the cylinder on them. Awesome. Hopefully that means I'm doing a good job and not that I've gone way over your heads. Cool. So we're going to move into talking about LabVIEW tips and tricks. But before that, Tyler, I think we can go ahead and do the first trivia question.
Okay, let me bring that up there. Let's see here. Do you want to go ahead and ask the question? I'll get it popped up.
Sure.
And I'll have that going.
So the first trivia question is, what kind of folder in the Project Explorer is necessary for effectively using source code control with LabVIEW? So this is the folder within the LabVIEW Project Explorer that we really, really need to make source code control happen in LabVIEW.
And we did actually get a couple questions too, April, so I'll have you field those in just a moment here. So
Awesome.
once again, if you're interested in that giveaway, make sure you type in the answer. It is scrolling on top of your screen. You do have to be either following or subscribing in order to be eligible, so go ahead and start typing that in for your chance to win. So some questions that got asked on here. One from Bracken Cloud says, can we have a step sequence structure as its own VI?
A step sequence structure. I'm not quite sure what you mean by that. If you're talking about a case structure or something similar to that, sure, you can absolutely put that in a sub-VI. We'll talk a little bit more about that in a minute, but that can definitely go live in its own VI. That can go in your sub-VIs folder and then be used in your project as necessary.
All right, and the other question that we had was from Desolate10 asking, what is the best way to merge conflicts?
The best way to merge conflicts is very carefully. It's a little difficult to go through LabVIEW and tell what's different between VIs. If you do Google for this, it is on our ni.com/diversity as well. There is a program to kind of diff to LabVIEW VIs to go through and point out all the differences. It's not perfect, but to really resolve those conflicts, the best way is to just kind of go through the two VIs manually, figure out what's different, and determine what changes you want to keep.
So we're getting a lot of answers to the trivia question, but I don't know if I've seen a correct one yet. A lot of people are typing in virtual folder, April.
So we talked about virtual folders, and we talked about replacing our virtual folder with a different kind of folder in LabVIEW. It might be blue with a yellow cylinder on it.
And it is one word, by the way. I know some people can
Yes.
type it with hyphens or spaces. It is one word. So we'll see what people start typing in. I think we might start getting some correct answers soon.
All right, awesome. I promise the next trivia question is easier, guys. I promise.
So we'll let this run for a couple minutes, guys, and then we'll jump in during the presentation and pick a winner. Oh, by the way, I always forget to show what we're actually giving away for this. And I have this ready, by the way, so I do want to show this because these are really cool. If you haven't had a chance to see these yet, let me just get that up and going. So with our first giveaway is going to be a AndyMark Robot Revolution t-shirt, Robolution t-shirt, I should say, from AndyMark.com. So if you do win, you'll have to make sure you shoot me a PM and let me know your shirt size too, so we can get that out to everybody. So good luck, everybody.
Awesome. All right, so we'll go ahead and jump into the top 10 tips and tricks for programming FRC robots in LabVIEW. This is also known as things I thought were important for you guys to know that didn't really fit anywhere else in the previous 3.5 episodes. So we're going to go ahead and go through these, and we'll stop probably after the first or second one to reveal the winner of the trivia question. Tip number 1. Should I put code in robotmain.vi? The answer is no. Don't ever put code in RobotMain.vi. RobotMain is the primary control loop for your robot. So that's the actual VI that's running every 50 milliseconds to make sure your robot is communicating with the driver station, that it's talking to all the motor controllers. It's doing a lot in the background that you can't really see on the block diagram for RobotMain. So it's pretty critical that that runs at the time rate we have it set as. That's why we have SubVIs in there, because those are allowed to run at different rates from RobotMain. The biggest issue you'll probably see if you do put a lot of code in RobotMain is you'll start seeing communication issues with your robot. It might drop out kind of sporadically. It might disconnect every single time. So just kind of don't put code in RobotMain. It would be my recommendation. No one's going to stop you from doing it, but it could lead to problems down the road, and you don't really want to introduce any unnecessary bugs in your system. Tip number 2. What is the Periodic Tasks.vi for anyways? It kind of sits up there in RobotMain. Sometimes it gets used, sometimes it doesn't. Periodic tasks is for any action you want to perform periodically. And this is basically anything you want to happen at a set rate, regardless of what else your robot is doing. It's most often used for sensors and things like that, and you can add in additional loops if a different rate is needed. So we're going to look at this a little more closely. Looking at the next slide, this is by default what's in your Periodic Tasks VI. We have 2 different loops here. The top loop you can see is things that happen every 0.01 seconds. So if you need to read from a sensor really quickly, you can put it in this loop. The next loop down is where your 100 millisecond tasks would go, things that happen every 0.1 second. So you can see that we're changing the rate of these loops depending on how quickly or slowly they're ticking. So what have we set that tick value to in the bottom right-hand corner? You'll notice that that value is in milliseconds, so be wary of that. If you set that to 1, things are going to happen really, really quickly, and you might not want that. So just be cognizant of that. If I wanted to add my own whatever to periodic tasks, in this case I've added a gyro sensor, you can see I've made a new loop because I decided I wanted my gyro sensor to update every 20 milliseconds. So I made a new loop for my 20 millisecond tasks. I set my gyro, my get reference for my gyro. I called it gyro, I'm very original. And then I'm just getting the angle and printing it out to a global data, to a global variable. That's kind of why that gyro angle output looks a little funny. It's not going to the front panel. If you open your Robot Global Data VI from your Project Explorer window, you'll notice it doesn't have a block diagram. That's intentional. It's just designed to hold any variables you want to share around your robot project. So I can update this gyro angle variable here and then read from it anywhere else in my project at any point in time. And it's going to get the last value from that gyro update, from that gyro angle. Do we want to do that giveaway, Tyler?
Yeah, we can go ahead and do that. So let's start doing the drawing. Once again, that's for the Andy Mark t-shirt. The question, can you read the question off one more time? We'll do the drawing on that.
I certainly can. So the question was, what kind of folder in the Project Explorer is necessary for effectively using source code control in LabVIEW?
All right, and what's the answer for that one, April? Of course, it's obvious. I mean, I knew it.
The answer was auto-populating. So you
Auto-populating.
need those folders to update from what you save in Windows before you can really do source code control in LabVIEW.
Cool, and congratulations to JCB486 for winning the Andy Mark t-shirt. Make sure you do shoot me a message in Twitch here with your mailing information as well as your t-shirt size. Congratulations.
Awesome. Cool. So yeah, just to recap, periodic tasks mostly used for sensors, anything you wanted to happen at kind of a set rate separate to the rest of your robot project. It kind of happens on its own, but it's a great place to put sensors and get those values back. Looking at the next one, 3 is how do we make a one-shot button press? One-shot button presses are kind of what you want when you only want an action to happen once per button press. So when you hold down a button, that value is going to be continually updating as true. So if you're reading in a false, because all buttons are Boolean values, you're going to be reading false, false, false. You press the button. If you keep holding it down, it's going to start reading true, true, true. If you have that true wired into an action, for example, pick up a cube or lift something, and you only want it to lift once, you only want to make that true happen once. For example, you don't want to say true lift and then you lift it 6 inches and then you say true again and it lifts it another 6 inches, and you can see where that's going. So this is called, my team calls it you only press once. The button's only going to happen once. Yeah, we call it a YOPO, exactly. So this is the code you would want to use to build a one-shot button press. That input terminal on the left there is going to be your button in, so that would be your initial button value, and that top wire is going to have the current value of the button. Looking at the wire that kind of goes down and around, we run into what's called a feedback node. This preserves the previous state of the wire that it's on. So in this case, it's going to continue to preserve that false value that we see we wired into the bottom there, because our button should be false by default, and then when it goes true, we want to see that. So this value coming out of the feedback node is going to continue to be false for a long time, and then until we press the button. So when we not this value, and we run it through this little not gate here, that's going to invert the false to a true. Not just means stick a negative sign in front of it, basically. So if you take the negative of a false, you're going to get a true. And then that true value gets wired up into the AND gate. An AND gate is a type of comparative logic where you only get a one output or a true output if both of your inputs are true. So I'm constantly wiring in a true value to the bottom of the AND gate, and then that top value is going to be the current value of the button. So it's going to be wired with, most of the time, false on the bottom and true on the top. That combination of a 0 and a 1 through an AND gate is going to give us a 0 output. So our button pressed Boolean is going to stay false. Now when I press my button, it's going to tick to true, that top wire, and then our AND gate is going to have a true and a true input. That true and true input is going to give us a 1, and our button pressed Boolean is going to light up because it's true. Awesome, great. Now we only want this to happen once, right? So this is the key part of the way we've set the code up here. The next time this runs, we're going to theoretically still be getting a true value from your button because you're holding it down. You're really excited. You're just holding that trigger down. So that top current value of the button wire is going to stay true. However, our feedback node is going to update to be true now because that was the previous value it got. And when we not that true value, it's going to turn to a false. So now when we go to our AND gate, we're going to have a true on the top and a false on the bottom and get a 0 output. So we really, truly only get a true value once. That's kind of the power of the one-shot button press. And that's the logic we'd use to get there. You can find this on na.com/FRC if you want to look at this further, and I'll post the slides as well as always. Yes, that's the one-shot button press. Great code to kind of keep in your back pocket. So tip number 4 is kind of making a SubVI. How do I do this? Why would I want to do this? We're going to look at that, and then a couple different ways to make a SubVI. So SubVIs are really similar to functions in a text-based language. They're those kind of little blocks you see all over a LabVIEW block diagram that have another level of a front panel and a block diagram behind them. This lets you develop very modular code. It helps make your LabVIEW code more readable, and we'll kind of see why in a second here. It cuts down on the amount of blocks you have to read through to understand what's going on in the code you're looking at. It can also help produce spaghetti code. It's kind of what we call LabVIEW code that's out of control. Wires are going everywhere. It starts to look like a pile of spaghetti. I highly recommend Google image searching LabVIEW spaghetti code. You'll see some very terrifying pictures of LabVIEW. But SubVIs also help make your code easily reusable because you can drag them out of the Project Explorer window into any other VI without having to rewrite the code you already wrote. We would all like to write less code. So there are 2 different ways to make a SubVI. You can make a SubVI by going to any new in your toolbar, go to New and VI. You can also select code to convert into a SubVI and go to Edit, Create SubVI. So we're going to go through both of these steps in a little bit more detail here. We're going to start with looking how to make a SubVI from the new VI. Again, you click on, File, New VI to make a new SubVI, or from your Getting Started window, New VI is there as well. I just took the Yopo code and put it into a SubVI. So you can see that I've got the same code I had a couple slides ago. It's now in its own block diagram. And then the corresponding input terminal and output terminal are on the front to represent our button in and our button pressed. You can see that I have a little red square drawn around these 2 icons in the top right-hand corner of the block diagram. These are really critical when you're making a SubVI. The one on the left with all the little squares in it is called, and I'm blanking on what that's called. That's fine. We'll get back to that. But that's where you connect your wire terminals and set everything up there. The one on the right is actually your SubVI icon, and that's customizable. So if you go to the next slide, you can see that I've clicked on the square in my connection pane. That's what it's called. It's a connection pane. I've clicked on the top left square in my connection pane, and it turns that darker color. And then I've clicked on my button in terminal. You can see that it's got that kind of blue dashed border around it. That means I've selected that terminal. That's going to tie my button in terminal to that spot on my SubVI, so that when I go to put that on another block diagram, that's where I'll connect my wire to indicate that button in terminal. We'll look at that a little more closely if it's a little confusing, but I repeat the process for my button pressed. I click in the upper right-hand corner, click on my button pressed indicator, and then those two are tied together. You can see that there are two little green squares in my connector pane now. Those represent my two Boolean inputs. Those colors are going to match whatever color your data type is. So looking at the next slide, this is how we would create a SubVI from code that's already on our block diagram. So say we're looking at teleop here. It's kind of the example we're going to be working in. I've put in my YOPO code for my one-shot button press, and then I'm doing something in a case structure. I haven't decided what yet, but something's going to be there. And I've decided that this is really bulky code to have on my block diagram. And maybe I want to use that one-shot button press somewhere else. So I can click and drag around the code so that it's all highlighted again with that blue dashed border. And then I can go to Edit and Create SubVI. When you click on Create SubVI, if you go to the next slide, you will see what it does. It creates a SubVI for you. And if you double click on the SubVI, it opens up a front panel and a block diagram. You can see that they've already gone in, made our terminals, connected them to our connector pane, put it all in its own VI, all automatically. It makes the process of creating sub-VIs, especially for little code snippets like this, really quick and easy. So the last thing we would need to do, and we would want to do this if we made a sub-VI kind of by ourselves, is click on the sub-VI icon in the top right-hand corner. You can see in this picture that it's kind of a generic, it's got some LabVIEW looking symbols on it and a number. This just happened to be the 5th sub-VI I made when I was making this example, but we want to double click on that, and that will bring up the sub-VI icon editor. So looking at this editor, you can see that I've made it a pretty color. I've added some text to it. I've gone into the glyphs tab and searched for button and picked something that is descriptive of my VI. We really, really want this to be descriptive. The more descriptive you can make this icon, the better, because then I know what I'm looking at when I look at your code, when someone else looks at my code. It makes it a lot more readable. I said that sub-VIs help make LabVIEW more readable. It really helps if your sub-VI icons are descriptive. If you just end up with 15 of those generic sub-VI icons numbered 1 to 15, it's going to be really, really hard to tell what your code is doing. So looking at the next slide, you can kind of see this in action. You can either click and drag from the Project Explorer to drop your sub-VI on the panel, or if you selected code and created a sub-VI from that code, it'll already be there. But this made my code a lot more readable, and it made my code a lot cleaner. That YOPO code is kind of big and messy, and this helped make it compact because it's not critical to what's happening in teleop. We are on slide 4, making a sub-VI, slide 36 in the deck. The one after the icon editor. Sorry, guys. Yeah, so this is kind of the LabVIEW code I was talking about. You can see that it's a lot cleaner. It's a lot neater. My wonderful button press icon is there. You can color code all of your icons if you want, if they all have to do with one subsystem or one certain function. Color coding is a really easy way to note that those sub-VIs are related. Cool. So, tip number 5. Quick drop to speed up programming. This is kind of one of these sneaky things about LabVIEW that you don't realize until you've been programming in it for too long and you realize how much easier it could have made your life. Quick drop lets you get the functions of VIs you need faster. You get to quick drop by pressing Control and the spacebar, and it pops up in the middle of your LabVIEW screen, kind of like an instant Google search of LabVIEW VIs. You can just start typing in the name of whatever function you're looking for, and it will find it for you. So in this case, I opened Quick Drop with Control and the spacebar. I started typing an index because I knew I was looking for this index array block. It figured out what I was looking for, and when that when the block you want is highlighted blue, you can either press Enter to have it appear on your mouse pointer so you can drop it, or you can just click anywhere in the block diagram or the front panel to drop that block. Quick Drop automatically updates to search the correct palettes. So if you're on the front panel, it's going to search the palettes for the front panel. And if you're on the block diagram, it's going to search for the palettes in the block diagram. It makes everything really, really quick when you're trying to sort of code along, especially once you learn what functions and things like that you need. It will also include any SubVIs that you have added to your Project Explorer will get added to the Quick Drop index as well. Do we want to do the next trivia question?
Yeah, we go ahead and do the next trivia question. Let's get that up on the screen. Woohoo! We're on number 6 next, right?
Mm-hmm.
That's good math.
Mm-hmm. I'm proud of you, Tyler.
Thank you so much. All right, let's get the next trivia question. Do you want to go ahead and ask it? It's
sure.
A toughie, April.
All right, guys, I believe in you. You can do this. Should you put code in the robot main.vi? Should you put code there?
And how many words is the answer?
It's one word.
Okay, one word.
One word.
All right, so if you're interested in this as well, go ahead and type in the answer in the chat. Make sure you do follow or subscribe. And the giveaway that we're going to be doing for this are some 4-inch compliant wheels from Andy Marks. If you haven't had a chance to see those yet, they're pretty sweet and can do some pretty cool things for your robot in regards to some intake or other mechanisms you might do. I even saw, April, I don't know if you know, I saw some FTC teams actually use compliant wheels this year on their input. It's pretty cool.
These are super useful little wheels to have on hand. Always good to have spares if you are using them in a build. This is a really super cool prize, actually. I love compliant wheels.
Very cool. All right, so go ahead and start putting the answers. Most people, I think, might be correct. So we'll see how it turns out. We'll draw that winner in just in a couple slides here, guys.
All right. So jumping into tip or trick number 6. What index is this button on my controller? You can pretend I'm holding a controller and I'm pressing a button, and I want to know what index is my A button? What index is my Y button? What index is my right trigger? A really quick and easy way to figure this out: connect the joystick in question to your computer, plug it in via that USB port, and then open up the driver station and go down to that 4th tab on the left. This is the USB devices tab. You can see here that I had a Logitech dual action Xbox controller plugged in at the time. And I was pressing some button. As you press buttons, the corresponding index for those buttons will turn green. So in this case, I was pressing the 11th index button, I think, if I can count right, or 14th. I can't count. But these are numbered starting at index of 0 through however many buttons your joystick has, your joystick or your controller. You can also see that the 4 axes, I had 2 joysticks on this controller, those 4 axes are defined, and if I were to press up on one controller, the corresponding axis would move. So this is the best way to figure out what button corresponds to what on your joystick. You can also see from this picture that I didn't have anything else connected to my computer. I didn't have a RoboRio. I didn't have any robot code. I was just running the driver station and had a joystick plugged in. So this is something that's really easy to do as a programming team if mechanics is working on the robot. If they have the drivetrain, for example, because they're making some modifications, this is something you can do without any of that hardware. Now, you might be asking, what would I want to do with this information? Well, if we look at tip or trick number 7, how do I get the data from that button index? This is going to bring back that index array block I talked about earlier. That is located on the array palette in the block diagram. It looks like the block on the left when you first drop it down, and it has one input for the index on the left, and it'll output the relevant spot in your array on the right. So you can see here we already used these in Teleop to do the joystick split out for the arcade drive, but I've added an index array block in my sample code on the right because I wanted to get to index number 11 on my array of my joystick. I decided that was the button I wanted, so that was the index I wanted. So you can click and drag. If you mouse over the index array block, you'll get these 2 little blue blocks on the top and the bottom. You can click and drag downward to show more indexes. And if you haven't wired anything in on the left side of this block other than the array, the index value will correspond to the value of the number of drag downs that you have. So in this example, I sat here and dragged this down exactly 11 spots, or exactly 12 spots, so I could get to the 11th index. These are kind of hard to count, especially if you're older and wear glasses to read computer screens. So this took a minute for me to sit here, drag these out. You can also, if we look at the next slide, actually wire in a numerical constant for the index that you want. So instead of dragging it all the way down, I said, I just want the 11th spot. So I wired in that 11th index. Technically, this would be the 12th spot in the array. Remember that it's 0 indexed. So I wired in an 11 here, and that's going to put out the 12th value in my total array because it is 0 indexed. So these numerical constants can be really, really helpful. It makes things a lot faster if you know you only need one input, for example. But as you see that we've done for the joystick values for the arcade drive, if you know that you need the 0th, so the first and the second, the 0th and the first, spots in your array, they're not necessary. They can just make your life easier. You can also see that coming out of the index array, the wire values are preserved to the data types that you wire in. So in this top index array block, we've wired in an array of numerics. So those wires coming out are still going to be orange because the data values on that wire are still numeric values. Similarly, for the one we have going to our case structure, it stays green because the Boolean array we wired in is still a Boolean value on the way out. It's just one specific value rather than the whole array. That's why those wires coming out of the array blocks are a little bit thinner than the ones going in. The thicker wires are meant to indicate arrays. The thinner wires indicate single values. Do we want to wrap up that giveaway?
We can do the giveaway for it. Absolutely. Let's get a winner. So, oh, by the way, the answer is only if you want to work at SpaceX, right?
No, just kidding. Don't do that. The answer is no. Don't ever put code in Robot Main. It can only lead to bugs and heartache and debugging time down the road. Everything should go in a SubVI somewhere.
Fair enough. All right, the winner for that is Harish 786131809. Congratulations, you won the Anywhere Compliant Wheels. Please make sure you reach out to me with the PM with your name and shipping information so we can get that out to you. And thanks to AnyMark for doing the giveaway for that, for the trivia questions. And don't forget, we have one more trivia question, right, April? And then we are going to do the RoboReel giveaway. So make sure you get everybody from your team in chat and ready for that as well.
Awesome. Cool. So moving on to tipper trick number 8. This is, do you need a case structure? So kind of building on, again, this example we've been working with, I have my Yopo button press wired into a case structure. And you can see that I have the true case shown here. We can assume that the false case is wiring a 0 into this ARM motor that I've added to my project. This works. This is valid code. Typically, you want to use the case structure when you either have more than 2 options. So if or if you have a selector that is not a Boolean. So if I was going off of a numeric value, for example, if I was reading in some sensor data and I wanted one motor value if the sensor data was less than 0.25, I wanted another motor value if it was between 0.25 and 0.75, and I wanted a third motor value if it was greater than 0.75, I would definitely want a case structure there. That is the perfect use case for it. However, if I just have this Boolean selector here and I just have a true and false case, we can actually simplify this a little bit more. Case structures do make it a little bit more difficult to read your code because I don't know what's going on in this false case. I have to sit there and click to it and be like, oh, okay, now I understand. That just kind of gets stacked up if you have multiple cases. So if you have a true-false case structure, particularly if it's one value you want to toggle back and forth, if we look at the next slide, we can convert that case structure to use a select block instead. So all I've done here is I went and deleted my case structure. I grabbed the select block, and then the select block works in the way that you wire a Boolean input to it, so it only has a true or a false output. Your top input is true, and your bottom input is false. So if my button press returned a false, it would wire a 0 into the set output VI. If my button press returned to true, it would wire a 1 into my set output VI. This makes my code a lot more readable right here because I can clearly see what my two options are. I know what the logic is. I kind of know what's coming. Again, just makes your code a little bit more readable, cleans it up a little. But those case structures are super useful if you have any kind of non-Boolean input. So again, if you're choosing off of a numeric, if you're choosing off of a string, if you have an enum, any of those inputs, you'll want to use a case structure. Boolean one-value toggles, typically you want to use select. The select VI works a lot like the index array VI in that if I wire the output terminal to a data type, the two input terminals have to match that data type. So if I wired that into a string, for example, if I was outputting a string, I wanted to toggle between two different motors entirely, I would need to put an input string on the top and an input string on the bottom rather than the numerics you see here. So tip and trick number 9 is using controls and indicators, and how do we use them effectively? So constants on your block diagram can be converted to front panel controls. I've highlighted the two constants that I have that I'm going to be looking at here because these are the ones that make sense to want some control of. Having a control versus a constant allows you to adjust values at runtime, and it kind of can help remove that need to build and deploy every time you want to change value. If you are just making an indicator or a control, you're going to want to run your project interactively. There will be a couple of additional slides in the presentation I upload tenai.com/FRC that goes through how to make these into controls and indicators that show up on your front panel. But what I wanted to look at a little bit more closely here was how do I actually print these back to the dashboard? Because that's a little bit more applicable in the FRC use case and probably something you guys will want to know how to do. So if we look at the next slide, you can see that I have made my code a little bit more complicated here, but let me talk you through what I've done. So we're going to be sending these numbers to the dashboard and getting values from the dashboard. So if you look at my input terminal on the select VI, this is the value I have called arm motor set point. This is going to be the value I want to set that arm motor to. The neat thing about setting it up this way is it allows me to build and deploy my project once, and then I will be able to adjust this value live from the dashboard while I'm actually running my robot code. So I can set it to 0.5 and execute my arm action and be like, wow, that took forever. I need to make that a little bit faster and make those adjustments to find out what the optimal value is without needing to rebuild, redeploy, rebuild, redeploy, rebuild, redeploy. So this block here is called the NT read value VI. It does automatically adjust to whatever output you wire, whatever inputs are you wire it into. So in this case, you can see that it's turned orange, it's a double, and we're reading an NT read number. That drop-down VI, that blue drop-down on the bottom, you can click on it and select if you want it to be a Boolean or a string or something like that. So these are adjustable to whatever you need their functionality to be. The important part to note about this VI and the one we're going to talk about in a second is that pink string on the left-hand side. This is defining what control or indicator it connects to on the front panel. So kind of keep that in your mind. We'll look at that a little bit more closely in a second. Looking at the other VI I've added, this is the NT write value VI. This is going to write values back to the dashboard. So in this case, I want to know what my value was after I pressed the button or after I did something. So I've added this VI wired in my output of the select terminal, and it's going to write this back to the dashboard. Again, I've picked the right number version because I'm working with numerics here, but if I were working with strings or Booleans or anything like that, those options all exist. Note that I've called this one arm motor value because that's the actual value that's getting sent to the motor. You can also tell that their functionality is kind of indicated by their SubVI icons. The read number has a little pair of glasses on it, and the write number has the little pencil on it. So how do we make these talk to the dashboard? Looking at the next slide, All I've done here is made a default LabVIEW dashboard project. It opens up with this front panel. It looks just like the dashboard, but I've gone to the custom tab. You can see it's the fourth one over, and then I've just added a control and an indicator. The control is on the left-hand side, and it is called arm motor set point. It is critical that the name of your control on the dashboard and the name that you wired into the read or write VI in your teleop code or wherever you're setting those values are the same. Capitalization matters, spelling matters, punctuation matters, spaces matter. They have to be exactly the same string for this to work. So all I did was copy the text out of my pink string box from my teleop block diagram and paste it in as the name of this. Copy and paste is your friend. I've followed the same process for my arm motor value on the right-hand side. That's just an indicator. So when I deploy this code to my robot, like I said, it's going to go ahead and read these values as they update on the dashboard. So I can click that arm motor set point up to 0.5, and that motor value is going to be set to 0.5 when I press the button. It will also print out that arm motor value as soon as it gets sent to my motor. So this can be a really helpful way to speed up some debugging, speed up some setting control loop times, for example, or setting up a PID can be made a lot faster using this kind of technique. Do we want to do the last trivia question before we get into tip or trick number 10?
Oh, I'm sure everybody would be okay with that. So let's bring that up here. Give me just a moment once again. And all right, go ahead and ask the next trivia question.
All right, our last trivia question is, what function is used to get individual values out of an array? We talked about this function. It's 2 words. What function is used to get individual values out of an array?
And one of the words might even be in the question. You never know.
I don't know. Maybe it is, Tyler.
All right, so go ahead and start typing that in. If you know the answer to that, you'll have a couple minutes before we draw a winner. Please make sure you do either click that little follow button up on your screen or subscribe for a little bit extra luck.
Awesome. All right, yeah, and then my last point, kind of still on number 9 with this dashboard, when you do want to add controls or indicators or graphs or anything to your dashboard, that's what this custom tab is here for. It's intentionally left blank. It even says you can delete this comment. This is your space to add controls and indicators without kind of messing up the way the dashboard looks. This will automatically integrate very nicely. It'll toggle back and forth from the full screen dashboard to these 2 individual windows, depending on what you have selected in the driver's station. So this is what where I recommend putting any of those controls or indicators to keep your dashboard clean and functional and working correctly. You can put them anywhere else. Do so at your own risk. Cool. So looking at tip and trick number 10. 10 is kind of addressing what we just talked about, but how do I see my wire values in real time? I'm setting some motor value, or I'm sending a certain command, or I want to know what output I get from this logic I wrote so my state machine can switch states, and I want to make sure it's returning the right state. How do I see those wire values in real time? I want to see this as my code is happening. Like we just talked about, you can use indicators either on the front panel or on the dashboard. It makes it really easy to see values as they're happening, particularly once you've compiled your whole project and sent it to the robot. However, if you are working on developing some code, or if you're working on, say you're developing a vision algorithm and you want to see what values are coming back from that algorithm in development, something that is really, really helpful to use is called probes. You can get to a probe by right-clicking on any wire and selecting probe. You can see it's the blue line there. This will add a probe to that wire. So if we go to the next slide, you can see that I have 3 different probes added to my code here. I have 1 on each of my orange numeric wires going into Arcade Drive, and 1 on my Boolean wire coming out of my Yopo button press. These probes will return the values as they happen. So you can see on my right-hand side, these correspond to probes in the Probe Watch window. This window automatically pops up once you create your first probe, And this is where all of those values will update. So if you want to see two values next to each other or kind of in one group, this is a really helpful tool. You can see that each probe is numbered. So 6 and 7 are my probes on the arcade drive lines or wires, and then 8 is my probe on the Boolean wire coming out of my UFO button press. And those correspond to the numbers in the probe watch window. So my top two are the lines going into arcade drive, and the last one is the button press one. You can also see in the probe watch window, probe number 8 actually says button pressed next to it because that's the name of the output coming out of that VI. So that again just adds a little context, adds a little clarity to what value we're looking at in the probe watch window. This is most helpful, like I said, when you're doing development on your PC. When you run your code interactively, these values will update as your code executes. It's really, really helpful to kind of see things as they happen. Like I mentioned, Vision is a really, really good application for this because it lets you see, oh, my set point's too high. Oh, I'm not getting the right values back that I expect from my test picture. Kind of happen in real time, and you can react to those on the fly. Yes. All right, that was my last tip or trick for LabVIEW. Do we want to finish that giveaway up?
We can do the last giveaway, absolutely. Do you want to go ahead and ask the question one last time, and then we'll go ahead and roll for that?
Sure. So the question was, what function is used to get individual values out of an array? And that is the index array function because it lets you return a value at certain array indexes.
So we're looking for index array. And the winner of that is going to be Chief281. Chief281, congratulations. By the way, we were doing another Andy Mark Robot Revolution t-shirt as well, too, for that. So congratulations. And make sure you shoot me a PM with your t-shirt size and mailing information. We'll get that out to you.
Awesome. Before we kind of talk about the last point I have, do we want to start the giveaway for the RoboRio?
We can. I also did see a question in chat, too. So
let's go ahead and get that question.
So, well, let's start the RoboRio giveaway, and then I'll grab that question that we have. Guys, make sure you do tag at First Updates Now if you do have any questions for it. So give me just a moment so we can get this up.
Mm-hmm.
All right, so RoboRio giveaway. So once again, April, I just want to say thank you so much because you guys have given away a RoboRio on every single one of these shows, which is absolutely incredible. And we can't wait to see who's going to have the chance to do it. So once again, guys, this is the time. You need the message. Everybody right now, get them in the chat. Get them going make sure they follow First Updates Now or subscribe as well, too, because this is your chance to win a RoboRio. I mean, these things are, what is it? If you want to get off the Andy Mark, what, $400, $500, something like that?
It's up in that range. These are high-ticket items.
$435. And that's a discounted price, by the way, because if you were to buy that normally, what is it if you're not in First?
The industry price for a RoboRio is just over $2,000.
All right. So just over 2,000. So once again, if you're interested in that, I mean, you can go to Andy Mark anytime and buy one if you want to, but we're giving one away right now. And to do that, you got to put in a special keyword into chat. And let's see if we can get that up and going. So April, what's our keyword going to be for the RoboRio giveaway?
Keyword for today is badges, BADGES. And you'll understand why I chose that word here in a couple minutes.
All right, so go ahead and type in badges in the chat, and that will get you the opportunity to win the RoboRio giveaway. So, April, I do have a question from S3529. What would you say is the number one selling point for LabVIEW? So, especially for FRC teams, why should they choose LabVIEW over a different programming language?
So what I think is really cool and special about LabVIEW, it kind of depends what your background is. If you're a new programmer, I had never really programmed when I started at National Instruments 2.5 years ago. LabVIEW was really the first programming language I learned, and I found it so easy and intuitive to pick up because I could see what was happening and I could understand how the logic was working rather than it just being kind of a jumble of words and commands and semicolons, and I really hope I remembered to close all of my parentheses. It was a lot easier for me to access kind of the programming fundamental ideas through a graphical programming language rather than also needing to worry about syntax on top of it. So if you're totally new to the idea, it's very, very approachable, and I think that's really cool. If you're an experienced programmer and you're like, I know what a while loop is, I don't need a picture of one, the value I see in LabVIEW, particularly for FRC, is kind of what we talked about a lot across the last few tips and tricks. How do you make updates in real time? How do you do this live? And LabVIEW gives you the power to see that. You can print, getting a little complicated here, but you can print back kind of the feedback graphs from a PID control and see how your system is changing in real time and adjust those inputs and to kind of correspond to where that system is going. And being able to make those adjustments and see the immediate reactions just makes debugging so much faster. It makes setting up things so much faster and really gives you a lot of power to play around with stuff. I know first runs on a timeline. I know it's week, almost 5, and everyone's really, really pressed for time. So being able to do things quickly and easily is really, really helpful in first. And I think that's what's really cool about LabVIEW.
Very cool. We did have one other question as well. This might be a little specific, so we'll see if you can get this. So FRC 4292 said game data, the WPI document talks about pulling the data in a fairly fast loop while disabled of about 20 milliseconds. How or where would we do this? He's confused. She is confused.
Great place for doing that would actually be in periodic tasks. So you can kind of do this 2 ways. I would approach this 2 ways. If you want to see that game data during teleop, put it in periodic tasks. Make a 20 millisecond loop for it like I showed back in tip 2. Tip 2 was periodic tasks. Make a millisecond loop, print that data to a global data variable, and you can use that anywhere else in your code. You can also use that in Autonomous. If you want to be really specific about getting your data in Autonomous, you could also put poll robot data or poll game data there. I would suggest putting it in periodic tasks, putting it in its own 20 millisecond loop, and putting that data to a global data variable that you can make in robot global data is the VI name. That's going to be the best way to get that data anywhere else in your project. And periodic tasks is going to start running as soon as robot main starts running. And robot main starts running as soon as your robot turns on. So you'll immediately start getting that data as soon as the field management system starts returning it to the robots, so you can start making actions on it at t=0 when the match starts. So I would put it in periodic tasks.
April, one other thing I want to bring up. There's somebody in chat that said they really need to win the RoboView because theirs actually, it seems like that broke or didn't work. So is there a way they can get in contact with NI support about something like that?
Absolutely. If your RoboView breaks, if you're seeing something weird, you don't understand, it's not imaging correctly, give us a call. We are here weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, from 1 to 7 p.m. Central Standard Time. We are based in Austin, Texas. So if you don't know what Central Standard Time is, Google what time is it in Austin, Texas, and you'll know what time it is here at NI Corporate. Give us a call. That phone number is 866-511-6285. That's going to be the fastest way to get in touch with us. Sorry, my voice is giving out on me tonight. 866-511-6285. Best way to get in touch with us. We're happy to talk you through any RoboRio issues. If there is something physically damaged with your RoboRio, if something's physically wrong, we can look into replacing that for you. Andy Mark does work with us on that, and we'll get that turned around for you as soon as possible. So definitely give us a call if something weird is going on, and we'll help you out as best we can.
Awesome. Thanks, April.
Cool. So we'll give that RoboRio the giveaway a couple more minutes to tick away. Looking at the next slide, this is my list of resources for this last kind of presentation. We have a couple of really good tutorials on doing source code control on ni.com/FRC in both versions. We have a sensor basics tutorial, how to set up your dashboard, motor control. Again, that command and control tutorial I referenced last week. And then that local and global variables, talking about that, how do you use those effectively? We have a walkthrough for that as well. Looking at my last slide here, 2 big things I want to talk about here. The first one is badges. We have 2 brand new LabVIEW for FRC, or I guess FRC in general badges. One is LabVIEW for Rio programming. So this is asking questions particularly around programming for the Robo Rio. How do you write effective robot code? Do you understand the architecture? Do you know what the teleop VI is? Are the kinds of questions you're going to see in there. That one is LabVIEW specific. The other badge we have is actually software agnostic. So any FRC team member anywhere can earn this badge. That's our RoboRio hardware badge. So this is specifically over understanding the RoboRio. What are the different inputs and outputs? What are those voltage lines? And how do you connect to them? Those kinds of questions, purely about the RoboRio and kind of the surrounding hardware. No LabVIEW questions in there, no Java questions, no C++ questions. So software agnostic, which I think is really, really cool. You can get to these badges on www.ni.com/FRC, and there is a big blue box you can click on that says Level Up with Training and Badges. These are really cool. We've worked really hard on them. Go give them a try. They are designed to be open book and open note and open ask your friend in the room. The goal behind them is to teach you guys the information. This is what we think is critical to know to do LabVIEW for FRC correctly, to understand the RoboRio. These are the pieces of information we and I think are really, really important. So take the time, look them up, understand what the question is asking. You only need an 85% to pass the badge, so I highly suggest you go give those a try. They're really, really cool. I'm really proud of the way they turned out. The kids on the team that I mentor for have had a great time taking them, learning from them, so hopefully you guys do as well. The second other cool update thing I want to talk about is we are starting to roll out a series of interactive learning modules through our friends at ThinkScape Enable. The first one went live on Wednesday, and it just kind of walks you through learning LabVIEW for FRC in a different format. If you don't find the tutorials approachable, if there's just a ton of content out there, you don't know where to start, you're kind of lost, I highly recommend you start checking out these modules as we roll them out. They walk you through it step by step. How do I set up a robot project? How do I understand what I'm doing in LabVIEW for FRC? This is going to be a continual effort here. Like I said, the first one launched on Wednesday, just doing LabVIEW for FRC basics, and we're going to continue to launch 5 more over the next couple of months through Champs. We're going to continue to roll these out so you can continue to ramp up and learn LabVIEW. I highly recommend you check that out as well. Again, ni.com/FRC, level up with training and badges. They're linked there as well.
Hey, April, what is ThinkScape that's mentioned on the bottom of this page that we're showing?
Yeah, so ThinkScape is the platform that Enable is the company, ThinkScape's the platform that they use to communicate content in a different way. So this is a lot more interactive than our typical kind of tutorials that we have on ni.com/FRC. This is kind of a click-through process. It takes you through steps. You go to different pages, you go page 1, you go through it, click on page 2. There are actually question and answer boxes, so you can type in an answer and see if you're correct. Your mentor can actually set up a class, and you can all go through it and they can see your responses and see if you're on track, see if you're struggling with anything. So it's a very, very interactive content delivery system. So you do have to kind of register for it. It's completely free. Just sign up with an email address so you can track your progress, and then you'll have access to the first module and the subsequent ones as we roll those out live over the next couple months. And if you do have any feedback on the badges or on the ThinkScape modules, the forums on ni.com/FRC are a great place. Please do not post the badge questions out there. We had some issues with that when we first launched it live. Please don't do that. If you do have feedback, let us know. We'll reach out to you. We're always happy to hear feedback as we kind of continue to update and innovate the way we teach LabVIEW for FRC.
So April, I think we can probably give away that RoboRio. I think it's about time. What do you think?
I think it's time.
All right, let's go and do it. So once again, if you didn't type in badges, you got about 10 seconds to do it here before that. So April, one thing too before we let you go, you do mentor an FRC team.
I do.
As well. Tell us a little bit about that and what's going on with them right now.
So I mentor Team 5052, the Robolobos out of Cedar Park High School. They're awesome. They're a fantastic team. I am actually on the business and marketing side. So proud of my kids for turning in chairman's on time. We actually turned it in last night, so ahead of time. That was great. But they're a fantastic team. They are definitely chugging along. It's definitely build season for us. We're in the full swing of finishing out our drivetrain, moving on to kind of our superstructure. So they've really been dedicated this season and have stuck to their initial design plan and are really committed to seeing it through. And I'm super proud of everything that they've accomplished.
Really, and what events are you competing at this year?
5052 will be at Hub City Regional in Lubbock, Texas, and at the Alamo Regional in San Antonio. And I myself will actually be FTA out at the El Paso Regional during week 5.
Very, very cool. All right, so let's do the RoboRio giveaway here, and we want to give a big, big congratulations to the winner of the RoboRio, which is going to be BDAROZ. Congratulations, you have won the RoboRio. Yay! Right. April, I got to ask. Last time, our buddy Caltran asked about giving away one of the older modules. Is that still on the table?
We're still looking to see if we can scare some up. If we do find some, we'll let you know. They're definitely useful for kind of fun side projects. I know my team personally uses the old Serio to run a carnival game, like one of those throw it through the ring type games that
Sure.
they take to different events. So we'll see if we can scare some of those up, and maybe those will be given away on future shows.
I think that's a great idea. We can definitely do that if you do find some of them. I think
They're
that'd be
fun.
super cool thing to do.
Mm-hmm.
Absolutely. Well, hey, April, just want to thank you once again so much for you and National Instruments for giving these seminars, which are really great information about LabVIEW. Of course, the amazing giveaways, and we also thank AndyMark for their trivia giveaways as well. If you want to catch previous episodes, go to the NI First Robotics YouTube page where you can find the previous episodes. We do have them uploaded on First Updates now as well. There's plenty more to learn about LabVIEW, as April said, so make sure you check out some of those amazing resources that they have as well. And we want to thank everybody for helping make this show possible. And if you want more First Robotics in your life, if you like what we do here at First Updates Now, click that little follow button. Make sure you stay up to date on everything we got going on. We even have a week 0 stream coming up on Saturday that you can check out live as well. So if you want to see robots in action, probably for the first time other than the MCC robots, that will be your opportunity to do so on Saturday. So make sure you hop in for that. April, a huge thank you once again to you for taking the time and all your enthusiasm that you bring. Sometimes seminars, it can be one of those, we're here because it's neat, but you really put a lot of enthusiasm in it. I think makes this a great time for everybody. So thank you so much as well.
You're absolutely welcome. I have loved doing this. This has been super fun for me. I hope it's been helpful for you guys. That's really what we aim to do here is how can we make your lives easier? How can we get this information to you in a better way? So hopefully these have been helpful. Like I said, I've loved doing them. Hopefully I'll see some of you out at events this year or at Worlds in Houston.
Yeah, can't wait for that. Houston's going to be a blast, April. I'll see you out there as well, too, for that. So on behalf of everybody here at First Updates Now, we want to thank you for tuning in. Of course, thank you to April and National Instruments for supporting this stream. Thank you to all of our mods in chat as well. Hey, guys, we'll see you next time on First Updates Now. Talk to you then.